Okay, I think last week I've already discussed and described to you about the bill of material or the product structure. Same thing. Okay, bill of materials mean the list of materials that you need to produce the product, and then lead time. Yeah, we need lead time in order to produce the time phase product, which we did the exercise. Okay, so this is so-called the time phase product structure. So from the time phase product structure, because we know, for example, how long it takes to produce A, which is the final product. So this will take, it's actually taking 7 weeks. It's not 8 weeks, because we want at week 8, so we work backwards. We want at week 8. So when should we start? We should start at end of week 1. Okay, so end of week 1, then we start finish, and beginning of week 1, beginning of week 2, beginning of week 1, and finally beginning of week 8 we already have the product. So this is the time phase product structure. And the MRP structure, I've already explained to you, these are the data files, and you need the master production schedule before you can actually come up with the material requirement planning. Normally they use software. Okay, software is very easy. But I've seen software which are actually quite complicated. It's complicated, and it's there are issues, there are problems with MRP implementation in many companies. Theoretically, it looks very nice, but when we come to real world, some of companies face difficulty in implementing MRP. So they use just simple, straightforward planning. I've already told you about this determining gross requirements and how, and you have already done it. Okay, so start with the end item. Normally we start with the end item, then we work backwards. Okay, and this backwards, this step is lead time offset. What we mean by lead time offset? Lead time offset means we are taking into account the time taken for each component to be processed or purchased. Two things only: either you buy or you make the component or the child parts. So you work backwards, and finally you have the gross requirements plan. But this is not complete yet, because this is only the gross. Gross means the total. You need to, from here, how do we come up with the net requirements plan, or the actual quantity needed? The actual quantity needed. The actual quantity needed depends on how much stock we have in hand. Okay, so how much stock we have in hand, or we already have in the store or stock, then we can talk about the net requirement. Okay, net requirement. Net is after you reduce the stock in hand. Okay, so in this case, the item on hand is, item on hand means inventory. Okay, for A, there's already 10 inventory. B, there is 15 inventory. C, 20. D, 10, and so on. So when you do the backward, calculation to determine when should you order, or when should you actually have the components, then you have to work backwards. So A is the final product. So A, the final product. So what happens is that you minus the stock in hand. So 50 minus 40, it is 50 minus 10 is 40. So the net requirements is only 40. Okay. So this is a bit detailed. It's okay, no problem. So what happened is that this is the plan order receipts. Receipts, you already receive it. This is release. If you see here, release, it means it needs to be ready by week 7 before you can actually finalize the product at week 8. So it is because the lead time is the lead time is 1 week, so it requires 1 week. That means plan order release until plan order receipts. Okay, so this is at the product level. And you move down and you look for the next level, which is item B. Why you only need 80 is because you already have 10. So 40 times 2 is 80. What if, you don't have any stock? What should be the number here? Anyone can answer me. What if you don't have this 10 here? Anyone can answer me. If I do not have 10 here, so what become here is 50, right? The net requirement is 50. 50, 50, 50. So this is how much? 2B, 1A. So this is going to be how many units? How many parts?
120.
No.
No.
Not even 120. It is 50 times 2.
50.
100, Wakarimasu ka? So instead of 80, you must have 100. Okay? So, but in this case, we are requiring only 80, which is the gross requirements, 80. All right. Now we know we have 15 on hand. B, there is a 15 stock. So that's why you put 15 here, 15 stock. So net required is 80 minus 15, 65.
80 minus 15.
Okay, so that's how you work it out. You must minus the stock in hand to get the net requirement. Then you put the plan order receipts. This goes down here. And you minus, you take the lead time. Lead time is 2 weeks. So this is the plan order release, 65. Okay. So if you have 65 of B, you're going, for example, you order from vendor. So at week 5, you order 65 from vendor. And at week 7, it will arrive. It will arrive, then you can make A. So that's the idea, okay? That's the idea of actually, is moving from there. So same thing for C, you require 120, okay, 40 times 3, okay, if I don't remember, okay. So the same thing. And this is because of the lead time, then you get the plan order release. So I think the detailed calculation is for E also. For E, it has 2 paths. Okay, one is from B, one is from C. Okay, so that's why E is required for B, E is required for C. So you must track both. You must track or keep whatever quantity that is required. Okay, this is gross, then net. Right, so for C you need 200, for B 130 of E. Okay, E is required in B, E is required in C. Okay, so this work backwards for all the components, for all the parts. So these are all the parts. For example, G is required to be produced, starting produce week, what week is this? Week 1. Okay, week 1. Week 1, if you start week 1, then week 3, you guarantee to get it. Okay, and this will go into the next level and so on. Okay, so let's see this is how the explanation is. What I've explained just now is just like this, same thing. So start with production schedule for an item. If you have many, for example, you need at week 850, week 450. So you need to make to monitor both quantity required. Okay, I'll give you an exercise after this so that you can have a bit more complicated, but it's you can see how it works. So because there are 10 items on hand inventory, only 40 is actually required, which is the net requirement. Okay, so gross net requirement, the formula is gross requirement minus on hand inventory. So the planned order received for item A in week 8 is 40 units, which is 50 minus 10. So following the lead time offset procedure, that means you try to determine the planned order release for item A. Okay, the planned order release is 40 units. Then the in week 7. Okay, so you, because of the lead time, you need 1 week to produce A. Now you work for B. Now it's 80 units in week 7. This is the explanation for getting to that table just now. Just now, it is the actual table. So 15 units of item B on hand. So the net requirement is 65 units in week 7, which I showed just now. Okay, I showed you just now. B, you need 65 net requirement. Then the planned order release should be at week 5. So week 5 order, week 7 arrive, or you get the item. Okay. And the rest of the things. Okay, this is actually explaining the detail. The planned order receipt of 65 generates a planned order release. So this is receipt. This is release. You release the purchase order, you release the production starting. Okay, this is receive. So the on-hand inventory for item B is updated to reflect the use of 15 items in inventory and shows no hand in week 8. So this is referred to as the gross to net calculation and the third basic function of the MRP process. You need to monitor each and every components that is required. Okay, so you need to, it is a bit tedious, it is a bit meticulous, detailed, but if you make one mistake, then probably it will result into the what do you call the overall mistake. That's why you use computer. That's why they use software. Okay, they use software to actually do this. So if, for example, now you have 2 different products, so you have, that's why you need to monitor. This is gross requirement schedule. There is product A, this is product S, different product, but components is similar. Components is similar. C, B, C, B, C. Okay, and this is part, just small part of the product structure or bill of material. So if the lead time for A is 4 weeks or 4 days, or for that matter, lead time for S is 6, and the master schedule for A is this. At period 6, you need 40, at period 8, 50, 11, so on. And for S, you need 40 at week 9, 20, at week 11, 30. So this is, that means you combine it. You need to combine. For example, now, because, so this is the gross requirement of B. So you look here, B is required at weeks, A is required at week 40. Therefore, B, because of there is a 4-week lead time or 4-period lead time, so 6 minus 4 is at week 2. You notice here, 6, and this is period 2. So that's why it come here 40. 40 plus, okay, let's put that 40 first. 40. Here is 50, and here is 15 quantity here. And okay, another thing is this. Okay, this is the item which is actually sold directly. Okay, so this is also required, but it is sold directly. That means this is a part sub-assembly or part component. So that's why you have this plus 10 here. So this is plus 10 here. So week 1 you need 10 here. So week 2 you need 10. So 40 plus 10 is 50 at week 2. This is coming from here, week 3. Because 6 minus the lead time, okay? Lead time is 9 minus 6, week 3. 9 minus 6. So you see here, this is a gross requirement for B. Bit complicated, but you can do this because you have computer system to keep track of it. Okay, but it is messy. It's messy, but this is just one component. Jacob, this is just one component. You imagine making a car with 1,000 components, or for that matter, making a refrigerator or television. This is in manufacturing. Manufacturing is very complicated, very complicated. That's why people who are in manufacturing will, always think about how to make the process as efficient as possible. Okay, but of course not you doing this. Okay, not only one engineer doing this. There'll be a department taking care of production planning and control, and doing the scheduling and MRP. Any questions on this? Any questions? Do you understand this concept or not? Do you understand this concept of how they actually total up the B? You can do that for component C also if you want. Okay, you can come up with for C.
Gross requirement schedule is a bit difficult. I cannot understand this one.
Gross requirement schedule. This is actually a combination. If the key is this, if I have two products, so this is two different products. However, these two different products, for example, in a car manufacturing, we produce sedan model. Sedan is 4-door. I also produce 2-door model. 2-door model. 2-door, okay? Now, if B is the steering wheel, is it, and they use the same steering wheel on 4-door and 2-door, so B is required on both products. Correct. If you just understand that there are components which is the same and required for both products. Okay, and this steering is required. The lead time for A producing this is 4 weeks, and the master schedule is this. You need at week 6 40 of A. You need week 6 of week 8 50, week 11 15. So in order to get this 50 40, assume that B requires 1. Basically, this is 1-to-1. 1B produce 1A. So you need 40 Bs to produce 40A. So that's why on week 2, which is why you get 2, 6 minus 4. 6 minus 4. Remember, we work backwards to actually determine this. So this is 40. 40 plus 10, which is actually B. Imagine like this. B is used sold as spare parts. Spare parts. So B, not A. This A is the final product. B is the component. So the component is 10. Is required for week 1. That's why we have 10 here. Okay. It's only B. It's only B. You're not talking about the component C. You're talking about B. So we require 10 at week 1. We require 40 plus 10 at week 2. We require 40 at week 3 because of the lead time. Okay. So therefore, these are the gross requirements for B. Total is a total requirement for all the products as well as the spare parts. Okay. But this computer can handle this. Okay, computer can handle and actually total up the gross requirements. Okay. So it is. This is what happens in real life. That means you have to total up all at the same time. Okay. If not, you won't be able to produce S at week 9 if you don't consider the requirements for B, at week all these weeks. Okay. Anyway, just remember that there is you need to add up different for different products, the same component. So this is the logic of net requirements, which is gross requirements for plus. There are sometimes you need to put some allocation or parts which are actually or products which are already being promised. Allocation, they call it allocations. So this is the total requirements minus your on hand plus the scheduled receipts. Then you get your net requirements. Okay. So normally we use this MRP planning sheet. Just now we already used that. Okay, this is called the MRP planning sheet, but you can simplify this. You can simplify this because the net requirement and the plan order receipts are normally similar, same. So that can be combined. Okay, sometimes we need to consider safety stock. Safety stock is can be included in in the calculation. Okay, and it is you can include that in the on-hand inventory. Whatever you have on on-hand inventory is also considered as safety stock, because it's already if it is used up, then you need to put up some inventory as well. But it is built into projected on-hand inventory. Now, the management of MRP is actually very dynamic. Why we say dynamic? Because in actual production or actual what do you call planning, actual planning, things change. Sometimes things change. So if you change too much, too many, in MRP terminology is called as system nervousness. It's very difficult to keep on changing, the planning. You cannot keep on change the quantity change. Okay, it will actually result into at the end of the day you cannot implement or you cannot run the production. Okay, so that's why you need to have time fences. Time fences, that means you put limits on replanning. Replanning means we have a block of, for example, 1 week, 2 weeks. 2 weeks planning, this 2 weeks forward, no changes. You can only change after the 2 weeks. Okay, it allows changes. Actually, MRP allow changes, but if it is too much, then you're going to be waste your time doing the replanning. Waste time doing the adjustment. Okay. There's a term called pegging, which actually links each item to its parent. When one thing change, then you need to change the whole thing. For example, if the order changes, for example, from the master production schedule, suddenly it increased 10 more units. So 10 more units will affect the child parts. So you need to also increase the net requirement for the other affected components will be automatically what do you call, adjusted accordingly. Okay, so you cannot just change one, the end item only, because the end item is related to the to the child parts and also the parent. So pegging links each item to its parent, allowing effective analysis of changes that you try to do. But the limitations of MRP, that's why I say MRP has certain limitations. Okay, MRP does not do detailed scheduling. If you notice, it is only ball gross, okay, gross and net. Net is just showing how many you need. But for example, do you know, does it consider capacity? You know, you want 100 to be produced in 1 week, but 100 to be produced, do you have the capacity to produce 100? So that is something that that is not available in MRP, but it is available in MRP2. Okay, the material resource planning. Okay, so that is available for consideration, but in general MRP does not detail scheduling. It's only plan, very gross, and it works best in product focus and repetitive environment. So that's why I've been giving you examples of like car manufacturing or even food manufacturing. Also, it is applicable, it can be used because it depends on the product structure. And also it requires fixed lead time. But in reality, do you think that you can always fix the lead time? Is it in the real world, in industry, do you actually, when you order something, it is definitely going to arrive in certain lead time in real world? Now, Yaakob, in real world, is fixed lead time something which is confirmed? You can get fixed lead time? No, in reality, it's quite difficult. Okay, it changes. And infinite size time bucket. That means just now I mentioned just now the time buckets. That means 1 hour, 1 week, 2 weeks. This maybe you cannot assume infinite size. What if it is 1,000? Then you cascade down and you see 1,000 needed in 1 week, but you don't have the capacity. So it is related to capacity. So the limitation of MRP is sometimes it's a bit, it's very idealistic. Okay, I'm not going to go to this, but there are other MRP techniques that actually consider lot sizing in terms of the production depend on lot. Okay, lot for lot, especially if setup costs are high. Okay, so you try to reduce the number of setup so that you can actually produce more and it will become cheaper. So there are lot sizing techniques. I'm not going to go to this. It becomes a little bit more complicated because it will look into different, different plan orders, receipts, depending on the lot sizes. Lot size means how much you produce in one production run, okay, in order to minimize the cost. And I'm not going to. So what you do is actually you compare the different cost setup holding for different schemes, lot for lot or EOQ or POQ. Okay. Okay, I'm going to now. The extensions of MRP, that means after when you have MRP stands for what? Material requirement planning. Okay, material requirement planning. So when they move into MRP2, okay, MRP2 is known as material requirements planning. Okay, material requirements planning. So it become much more complicated, much more complex. But of course, it becomes much more real because you will have all kinds of what do you call modules? Okay, modules. So there are purchasing modules, there are production scheduling modules, there are capacity planning modules, there are inventory modules, warehouse. Okay, and not only the outputs is only product, it can include scrap, it can include packaging waste and so on. Okay, so it's generally called material resource planning. Okay, MRP material resource planning because it considers all the resources. Even though it says there material requirements planning. So the requirements data, there's more data basically. There's more information in the MRP tool. Okay. So for example, you can include the labor hours, the machine hour, the scrap, the payables, and it goes into the finance as well. That means you can actually connect to the accounting system, payment system. Okay, so MRP2 is much more complicated and bigger, right? From not only what you call planning, the master product schedule and the planning, but more than that. Okay, it goes. If, for example, you need to produce the computer, you'll put there the amount of resources. That's why it's resources. Labor hours, man hour, machine hours, scrap produce, payables, labor hours. Okay, for the PC board, 1 each. For the processors, 5 each. So it becomes actually much more real. It's much more reflective of the real world. Now, the MRP system must be closed loop. That means it will start from aggregate planning and you will go to priority management, because when you order certain products, you must actually decide. That's what we call priority. Decide which order to deliver first, when to order. Okay, then you develop your master production schedule. If it is okay, you prepare your materials requirement plan. If it is okay, you prepare your detailed production activity control. That is your shop scheduling or dispatching. And you must compare, that's why there is arrow here, with your capacity. Okay. You evaluate your resource availability. This is called rough cut. Resource availability. If you need to, for example, to produce 100 parts, 100 products, your capacity can only produce 80 parts. So you have to balance this. You have to check. So you evaluate availability, determine capacity availability, implement input-output control. Do you need to do overtime? Do you need to actually, delivery, you have to change the delivery date, you have to negotiate with customers whether you can deliver or not. Okay, so this is closed loop because it integrates with the aggregate plan. Okay, and always, all the time, you must remember that there is 2 stages. One is planning and then execution. You plan how many to produce next month. You must have all the materials, all the equipment. You order with the lead time, then only you can implement it next month. Okay. So execution, so in the repetitive system, JIT techniques are used. Even JIT also, we need to have certain lead time. There is no such thing as order, it will arrive. There's no such thing. There is always lead time. So that's why it is called closed loop. Sorry. That's why it's called closed loop MRP system, because it is from aggregate plan, then your master production schedule, which is your planning, execution, and of course it have to be monitored. Okay. No, in real life production, if you don't meet the production days output, you need to, if your target, for example, is 500 completed product. For example, today our plan is 100. Then you don't meet this 100 because of many reasons. My plant maintenance problems, parts delivery problem, you only meet 480. So you need to think about how to produce the -20. So this -20 will go back into the system to be planned. Okay, it is very dynamic, okay. So even JIT also, it is very dynamic. So closed loop MRP system requires this. Right. So in the MRP system, you will get feedback about your capacity planning. Feedback from MRP system is in terms of our capacity. When we have this number order, is it enough or not? And in the MRP, you can actually have load report. Load reports means how much capacity is being used in the work centers in that production area. Okay, what is the utilization? Okay, can it meet the promise what they call quantity? Of course, this is work can be moved between work centers to smooth the load or bring it within capacity if it is doing the same work. Okay, you can move from work centers if it is doing the same work. For example, this center is welding. So this is also welding. So that is if you have 5 welding machines, so you can actually move around between the welding machines. Okay. You can move in order to smooth the load or bring it within the capacity. There are many ways of smoothing tactics, overlapping the work, operation splitting. Okay, I'm not going to go to this detail. This is very detailed about how we actually assign the work, whether we want to use one machine, 2 machine, whether we can, or even order splitting. Okay, order splitting. I mean, can we split the order? Can we, remember just now we say 100. Can we split that 100 into 50-50? Okay, so that's order splitting. So you break up the order into smaller lots. Okay. Operation splitting is splitting between machines. Overlapping means you try to send parts to the following operation before entire lot is complete. Before you complete the entire lot, you already deliver the new lot for production. Okay. Okay, I'm not going to go to this detail. This is requires adjustments and requires some manipulation. Okay, but the idea is this: if you have you can split the orders because there are certain days or certain days, basically certain days that probably you have extra idle hours that you can fit in, that you can actually move the order, or you can actually fill up the time to complete the order. So order splitting can also be done. Okay. Sorry. Right. Any questions? I know it's a bit not complicated, a bit theoretical, because you need to see in the real world. Okay, MRP in services. Some services or service items are directly linked to demand for other services. Okay, so this can be treated as dependent demand, restaurant, hospitals. So you can actually also use as a planning tool for your product. Remember I showed you that there are product structure trees. So you can also use this MRP planning to determine when you're going to order the materials and so on. Okay, of course you do not know because in services you do not know the demand exactly when it is required. Okay, because you don't order the number of hospital beds. You don't order the number of hospital beds. It is based on random people who are actually requiring the treatment. But in this case also, I do not know whether you actually will order exactly this cheese, chicken mac and cheese. Okay, for example, at week 10, you need 100 of this. You can plan. Okay, this is a gross requirement. You can plan, and then, for example, the lead time of certain material is, I don't know, 3 weeks and so on. So you can still plan using MRP as well. Okay, for this kind of product structure. Okay, so this is the bill of materials, and you need the lead time. Okay, you need lead time to order the. Okay, so you still can develop bill of materials for food products. Okay, for McDonald's or for Pizza Hut, they probably have bill of materials as well in order to produce their products. Okay, so it's actually applicable. You can use MRP in services as well. Okay, we go to other kinds of resource planning, distribution resource planning. This is a kind of method. Okay, it's kind of method in MRP as well. And today, if you see some companies, they go to the extent of not only just material, because material is very, very small. What's the meaning of enterprise? The whole business. Correct. The whole business, enterprise, the whole company. So enterprise resource planning or ERP. So from MRP, develop MRP2, and then it developed into ERP. ERP is enterprise resource planning. So it is an extension of the MRP system. So remember just now we talked about this, the closed loop MRP. Okay, but now it is extended to tie in customers and suppliers. So it's not only isolation between the company only, but it is actually integrated with the customers and the suppliers. And it allows automation and integration of many business processes. They share common databases about parts, component, inventory, okay, and also business practices, and produces information in real time. This today is very extensive. Okay, we also do not know in how much this they have actually implemented this integrated. It is actually integrated with the suppliers and the customers. It coordinates business from supplier evaluation to customer invoicing. Okay, so from customer evaluation right until customer invoicing. Right? It's very extensive, very extensive. So imagine modules mean in the software, it is a software. Basically, it's a system, it's a software. So there are modules. Module means one particular segment of the software that can actually take care of basic MRP, which we showed just now, basic MRP. There is a module for finance because you can connect the data here and generate your financial report, your costing, okay? And you can also generate, from your basic MRP, because if you need workers, how many workers, welders, so you have your human resource module. Then you have your supply chain module, your customer relationship management module. And also, of course, if it is, it's huge, this is big, not only huge, it's very, 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 very big system. Okay, very, very big. And you talk about sustainability when you want to report on, for example, the energy consumption, the wastage, the the carbon emissions. So it comes under the sustainability report from your production processes, because in basic MRP you have all your machines, your capacity, your usage, utilization. So it is, it's integrated. It's huge. But big things for big company is okay, but for small company, I don't think small company wants to do all this. Small companies probably is going to be costly, number one. Number two, they don't need a very complicated system to run a simple organization. Okay, so big organization, they have ERP, enterprise resource planning. So this is the whole. You imagine this is a big system. It's a software. So this is the MRP. MRP is only here. Okay, which is the master production schedule. Then you have inventory, the bill of material, the work orders, routing and lead time. Routing means the sequence of production, purchasing and lead time of the purchasing. This connect with the supply chain management module, vendor communication, electronic data interchange, okay, advanced shipping notice, e-commerce, order online, monitor online, okay, so supply chain. And because we have purchasing, we have delivery, so it goes into finance, accounts receivable, general ledger, accounts payable, payroll because it relates to our human resource. Okay, you can actually integrate with human resource. Okay, and customer relationship management in terms of your invoicing, sales order, shipping. So it is an integrated. That's why it's called enterprise resource planning. Okay, resources are very limited in organizations, so we need to make sure. So MRP, this is MRP, is very small. The whole thing is ERP. Okay, so this is an explosive view of the description that I mentioned just now. This is the MRP, just now the CRM, and this is the SCM. Let's play with short forms. SCM, supply chain management, CRM. So you should be starting to familiarize yourself. When someone say SCM, you should immediately know supply chain management. Okay, when someone say CRM, customer relationship management, and your MRP, finance and accounting. So ERP system have the potential to reduce transaction costs, because if you do automation and is integrated in digital, you will actually reduce transaction costs. That's because when you do manual processes, it's actually consuming a lot of time, and also wasted papers, wasted document, wasted forms. You fill up 10 forms to do the documentation. So ERP will reduce transaction cost, increase speed, accuracy of information. Also will facilitate strategic emphasis on JIT systems. If especially the company and the supplier is using just-in-time system, electronic data interchange, delivery, all online, real time, how many receive, how many order, okay, how many rejects, and so on. Then you will actually ensure, you will help, it will facilitate supply chain integration. But the fallback is it can be expensive and time consuming. It is actually expensive and time consuming to install. That's why I say it is probably suitable more for large organizations like, you know, Dell computers, or even probably the big players, Intel. But for smaller companies, probably you need a smaller version of it. And there is a brand, well-known brand, SAP, which actually have ERP system. Oh, you use it already, Yaakob? I think probably you have seen SAP.
Yes.
SAP, but probably you take.
I use the ERP system. There is not from SAP. There is our own local company. That is Greensoft ERP Management System.
Okay, so you take care of the financial matters.
Yes.
So I think you understand what I'm trying to say. Those who are actually working.
Yes, I use the ERP Management System. That was like Greensoft ERP Management System.
Okay.
Developed by our one software engineer.
So it is they develop according to the needs requirement for your own company. Actually.
Right, for my own.
So this is very customized.
Customized.
Yes. But you can get SAP's ERP. Someone told me that, you know, SAP is a bit too complicated. It's a bit too complicated. It's very, very complicated. Okay. So all these modules are there, right? Cash to cash covers all financial related activity, delivery, things designed to manufacture, production related, even production engineering, production design engineering, production engineering, plant maintenance. You can put in plant maintenance because production line, there'll be maintenance. Maintenance, there is spare parts. Spare parts, there is inventory. Inventory for spare parts and also replacement item. Okay. So this is, you know, when we started, we talked about MRP, okay, which is material requirements planning. But at the end of the day, it's actually can go big until ERP, enterprise resource planning. Okay, why don't we take a break, 5 minutes break? It's 9 o'clock. Then after the break,
yes, please. Thank you.
I'll give you one exercise for you to do, and I'll give you time. That after that we'll discuss about this exercise. Okay.